This is 4.1 G and trigonometry, graphs of the sine and cosine functions. And this table here I have is on page 138. You need to make sure that you have this written down. Very, very important. It gives you the steps in order to do these problems that I just went into. So I'm going to kind of keep that handy, and we're going to look at example number 4 and work our way through that. It's asking us to graph y equals -2 sine of 3x. Alright, so step 1 says find the period. Well, we know the period is going to be 2 pi over b, or 2 pi over 3. And so that's my period. Not real hard to find. Then we are going to find out what our interval is. Well, our interval is going to be 0, 2 pi over 3. Alright, next step. Divide your interval into 4 equal parts. Remember, we divide them into 4 equal parts so that we find out where important things are happening, because it always happens at those 4 equal part places, those dividing lines there. Alright, so let's go ahead, and if you remember, bottom of page 136, we took 1/4 times our interval, 1/2 times our interval, and 3/4 times our interval. And that gives us then intervals of pi over 6, pi over 3, and pi over 2. So we actually have 5 different places that we're looking at. 0, pi over 6, pi over 3, pi over 2, and 2 pi over 3. Don't forget your 2 endpoints there. Okay, next step. Evaluate the function for each of the 5 values resulting from step 2. So we've got our 5 values here, and we are going to evaluate the function based on that. And this is where we have our chart. So we're going to use each of these as our x values, because it's going to be along the x-axis here, each one of these, and we're going to find out what our y values are. So I'm going to get rid of all of this, but remember, these are going to be our x values. So I'll just redo those here in just a sec. So our x values, we said, were 0, pi, let me get myself a little more room. 0, pi over 6, pi over 3, pi over 2, and 2 pi over 3. Those are our x values. Alright, our original problem, I'll put it down here at the bottom, is y equals -2 sine of 3x. So that's my x value. I need to find out that. So I'm going to go and put 3x. So if I multiplied each of my x's times 3, because that's what I've got here, 0 times 3 is 0. 0, or pi over 6 times 3 is pi over 2. Pi over 3 times 3 is pi. 3 pi over 2, and 2 pi. Okay, but that's not my y value. Now I have to multiply it. Now I have to take the sine of it. Sine of 3x. So now I'm going to take the sine of 0 and get 0. I'm going to take the sine of that and get 1, and then 0, and then -1, and then 0. So notice what I did here. I took 3x. These are my 3x's. And it says take the sine of 3x. So I did that. I took the sine of each one of these. Now it's saying multiply those answers by 2, -2. So take the sine of 3x, which are all these numbers here, and multiply them by 2. So 0 times -2 is 0. 1 times negative 2 is negative 2, and then 0, and then 2, and then 0. So at this point, let me circle in yellow what I have. I have my x values, and I have my y values. So when x is 0, y is 0. When x is pi over 6, y is negative 2. When x is pi over 3, y is 0. When x is pi over 2, y is 2. And when x is 2 pi over 3, y is 0. So I have the commonalities here between this, x, y, x, y. Okay, so this is enough information here to graph it. So let's see if we can get rid of some stuff and actually graph this. So I'm going to put my graph here, and it goes to starts at 0 and ends at 2 pi over 3. And I'm going to have my halfway point, my quarter point, and my quarter point. So this quarter point is pi over 6. This one's pi over 3. This one's pi over 2. So what happens to y at pi over 6? At pi over 6, my y value is negative 2. So let's put that right there. What happens at 0? Well, I'm at 0, 0. What happens at pi over 3? I'm at 0. What happens at pi over 2? I'm at 2. And at 2 pi over 3, I'm at 0. So now I can draw my graph. I didn't even have to worry about, and let me write the original one on here again real quickly of what we were doing. Get rid of all this stuff. Our original problem was y equals negative 2 sine of 3x. I didn't even have to worry about what this negative did, or what the 2 did, or the 3. I just followed my steps, and it all came out. Notice though what this negative did is it turned it upside down. Normally a sign looks like this, but because it's negative, it flipped it over. But I didn't have to worry about that because it did it all by itself because I followed those steps correctly. Okay, let's look at one more example. Y equals negative 3 cosine of pi times x. So instead of a number in front of the x, we're going to put a pi there. Doesn't really matter. We're going to find our period. Our period is going to be 2 pi over b, which in this case is pi. So our period is 2. So we will graph our function over the interval 0, 2. And we will find our points, or our intervals here. Because remember, we take, here's my first one, my second is 1/4 times the interval. So that's going to be 1/2. And the next one, and the next one. And then my last one is 2. So I've got 0, 1/2, 1, 3/2, and 2. So those are my x's. So let's go ahead and put our x here. 0, 1/2, 1, 3/2, and 2. So those are my x's. Alright, now I'm going to do pi times x. So pi times 0 is 0. Pi times 1/2 is pi over 2. That'll be pi. That'll be 3 pi over 2, and that'll be 2 pi. Alright, now we're going to find the cosine of pi x. So we're going to take the cosine of each one of those. Cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. Cosine of 2 pi is 1. So we just plugged each one of these in and took the cosine. Alright, the last part of this says that we're almost there, we're almost at y, but now we have to multiply each one of these times negative 3. So it's actually negative 3 times the cosine of pi x. So negative 3 times 1 is negative 3. 0 times negative 3 is 0. Two negatives give me a positive. Get a 0 again. Get a negative 3. So here are my x values, and here are my y values. So then when I graph this, try to do that down here, my period is at 2, and I've got 1 in my quarter and my 3/4, or 3, yeah. I guess that's supposed to be 1/2, isn't it? And this is 3/2. Okay, so now at 1/2, what was my y value at 1/2? It was 0. What is my y value at 1? It was 3. So I'll say that's 3, 3. And then there, and then there. Oh, and at 0 I'm at negative 3. So my graph looks like this. And notice it's upside down, and again it's upside down because of my negative 3 there. Alright, so that is example number 5. So that's it for lesson 4.1. I am not going to do any of the problem sets because I've pretty much covered everything you need to know in order to do those, so you should be okay.